Hello. This video outlines the steps to program a 5-axis through-a-point milling of a port opening on the Murasaki NT machine using the Esprit CAM software that is included in the MAPS4 control. The machine we will be using in this video is the Murasaki NT 4300 DCG machine, which is an integrated mill turn center that fully combines a lathe with a machining center. This machine includes a main and sub spindle, a lower turret, and a B-axis, which gives it full 5-axis machining capability. This video will highlight the programming capabilities of the Esprit software, and in particular the Esprit Composite cycle. This cycle is a revolutionary concept in highly advanced machining functionality because it is based on the principle that any 5-axis machining function, no matter how complex, can be simplified into 4 simple, well-defined steps. Step 1 is to define the area to be machined. Step 2 is to define the shape of the tool path on the area that needs to be machined. For example, what do I want the tool path to look like on these areas? Do I want the tool to follow a parametric line of the surfaces, or maybe I want to cut in a back and forth or up and down motion, or I want to use the boundary of the surface as guides? So these are some various options that we have available that we want to choose from. Now, the third step is to decide how the tool axis will be orientated as it follows the tool path. Now, this is very important to the quality of the surface and whether I want a short or rigid tool is being used in tight spaces. In addition, angle limits of the machine tool need to be taken into account. How far the head or the table can rotate must be considered. And the fourth step is to specify how the tool should move at the beginning, the end, and in between cuts. Transition moves must be smooth to avoid witness lines and tool marks that will have to be polished out by hand later. Now here's the part that we will be using to demonstrate the 5-axis composite cycle. And as you can see here, we have the opening on the top, and this is the opening that we will demonstrate the 5-axis composite milling right there. So what I've previously done on this part is I've placed 5 machining operations on here, 2 facing operations, an OD rough operation, and then 2 drilling operations. So the next step is I want to show you in detail is the 5-axis composite cycle, and we're going to do that, as I said before, on that opening on this part. So the first thing we're going to do is define the area to be machined. And to do that, we're going to go ahead and place a freeform feature on the part. Now this freeform feature is distinct by the fact that it's going to let you select and save the surfaces that you want to machine, and also select and save the surfaces that you want to avoid, and it's going to place those all into one feature that can then be edited or changed in the future. So here I go ahead and select the area that I want to machine, that's green. Area I want to avoid in red, I select OK, and then I have this freeform feature that I want to use. So now I'm going to go ahead and open up the technology page, and the first thing I'm going to do is select the tool that I want to use. Now remember step 2, that's going to be define the shape of the tool path. Here, if you take a look at it, Esprit's given you 5 different ways to select from for a tool path. You may want to choose a parametric pattern, a project parametric pattern, parallel planes intersection, parallel intersection with a spline curve, or a contour offset pattern. In this case here, we're going to use a parallel planes intersection pattern. Okay, the next step that I'm going to do is go ahead and select the work plane that I want to do to produce that tool path, and I have one already predefined. The start, where I want to start the tool path, and then from there the ending distance, how far back I want to go. And finally, I'm going to select the step increment. The step over of the calculated tool path is based on this value. So I'm going to go ahead and put in 500 thousandths. Okay, let's move on to step 3, which is define the tool axis orientation. And as you can see here, Esprit gives you 4 different tool axis orientations to choose from. First, perpendicular to a drive surface. Second, through a point. Third, from a fixed vector. Or fourth, from a profile. Now, with these 4 separately definable tool axis orientation, Esprit makes it easy to try different tool orientations before deciding on the perfect cut. This is especially important when cutting tall cores or deep cavities with short, rigid tools. Full control is provided over the forward and back tilt of the tool, plus angle limits allow an axis to be locked in a 4+1 machining. So in this example here, we're going to go ahead and select our tool orientation through a point. And we can go ahead and, if we choose, we can select that point on the screen, and that point makes the tool pass through it when it creates the tool path. And then the last thing I'm going to do here is select my angle of limitations. In this case here, I'm going to say no limit, because again, I'm selecting the tool to always go through that point. Now, moving on to step 4, which we're going to be linking it all together and defining the links within an operation and between operations. So here first, we're going to go ahead and select our approaches, and that's how the tool approaches and leaves the part. Second, our feed links, and that's going to control the type of connection between adjacent cuts in our tool path. And then last is the rapid links, and that's used for rapid transition between passes or when the tool needs to leave the contact within the model. Now, Esprit gives you multiple choices, as you can see that I'm selecting here. And most importantly, it allows you to prioritize that list. It prioritizes for you automatically. So you can choose multiple options with Esprit using each option in priority order. Esprit will then try to apply the first link that appears in the list. If the link is not possible due to collision or out of limits, it will try the second link, and so on. Let's go ahead and click the OK button, and then we'll have Esprit go ahead and generate that 5-axis tool path. But what I want to stress here is with that 5-axis composite cycle, as you can see that with a single function design specifically for multi-axis machining in that page, Esprit gives you the ability to create your own customizable toolpath as a combination of available choices. In other words, by choosing from that list of 5 available machining patterns and from the list of 4 different tool orientation strategies, you now have 20 different ways to machine your part. Add to that the ability to lock an axis, and 5-axis toolpath is quickly converted to a 4+1 application. This provides you with a variety of choices and gives you the creativity to compose any complex 5-axis function with very, very few limitations. Okay, and finally, let's go ahead and click the play button on the simulation, and we'll go ahead and show you the Esprit solid simulation and verification. And this does come with the Esprit CAM software that is included on the maps for control. And more importantly, that's included here is the actual machine setup. So we're actually showing you the Morisaki NT4300 DCG machine, the setup actually of that machine tool, the kinematics, how that machine tool works with the main and subspindle, the lower turret, and the B-axis. So again, I want to thank you for your time and have a great day. Thank you.